Okay, everybody, so this is going to be part 2 of the Trig apps lesson. So what we're going to do is we are going to continue working with double trig triangles and finding missing sides. So the first question here says that Kathy wants to determine the height of a flagpole as shown in this diagram. She uses a survey instrument to measure the angle of elevation to the top of the flagpole and measures it to be 34.9 degrees. She walks 8 meters closer and determines the new measure to be 52.8 degrees. At each measurement, the survey instrument is 1.7 meters above the ground. So the question says state the nearest tenth of a meter the height of the flagpole. Okay, so first thing we'll do is we will mark the height of the flagpole with X. Okay, so I'll call that X. And what I would recommend that we do in number 1 in all of these types of questions is I would recommend finding all the missing angles. Let's just do that and get that out of the way. Okay, so a couple things we can do. We know that we have a right angle here. And if you look actually at that right triangle that you see, we have an angle of 90 and we have an angle of 52.8. So if all three of those add up to 180 degrees, we should be able to figure out the last angle in the triangle, which is 37.2. And then what I can do is if I can find the angle supplementary to the 52.8, so if I take 180 minus 52.8, that'll give you 127.2. And then finally, if I look at that skinny triangle on the right, I'll take the 127.2, I'll add to that the 34.9, that's 162.1. And if I subtract 180 minus 162.1, that should leave you with about 17.9. Okay? So what we're going to do then is use the law of sines, and what I recommended doing was trying to pick a side that is in both triangles, okay? So what I'm going to do is I'm going to first find, and I'll call this side Y in orange, because that side Y is in both of the smaller triangles. So let's start with the triangle on the right. Okay, I'll kind of highlight this. But I'm going to use the law of sines with that triangle. Remember how the law of sines basically works. We said that the law of sines is take a side over the sine of the angle. Okay? Side over the sine of the angle. So, what's the side given to us? 8 over the sine of the angle opposite that is 17.9 degrees. We want to find Y and then ask yourself in that yellow highlighted triangle which angle is across from the Y, and that should be 34.9. I'm going to cross multiply now. So it's going to be Y sine 17.9 equals 8 sine 34.9. We'll divide by the sine of 17.9 on both sides. And now I go to my calculator. I'll make sure you're in degrees, please. Okay, so I'm going to press mode, double check them on degrees. That's good. All right, here we go. 8 sine 34.9. I'm going to close parentheses. Divided by the sine of 17.9, and that should be about 1.4. Oh, no, I typed that incorrectly. I multiplied. Let me fix that. I was going to say that answer didn't make sense. Well, here we go. 8 sine 34.9, close parentheses, divided by the sine of 17.9. Okay, that looks a little bit better. Remember we said about 4 decimal places, so I'm going to say 14 point, I'll say 8920. All right, so now what we'll do is we're going to use that number And now we're going to try to go into the other triangle. All right, so I'll call this one the blue triangle. All right, we're going to do the law of sines again. Okay, I'll take that over here. So now let's use the side that we know, 14.8920 over the sine of. Now, in the blue triangle, opposite that is 90. Okay, x is the side we want to find, and that's going to be across from the angle of 52.8 degrees. All right, so 14.890 over the sine of 90 equals x over the sine of 52.8. We'll cross multiply. 14.8920 sine 52.8 equals x sine 90. If we divide by the sine of 90, that'll give us what x is. So we'll go back to our calculator. So we're going to take that number. Now the good news is I actually have that number in my screen right now. So if I can press up and hit enter, it'll repeat that number. All right, I'm going to multiply that times the sine of 52.8. I'm going to close parentheses. I'm going to divide that by the sine of 90. And our final answer should be about 11 point, and they want this to the nearest tenth, 11.7. Excuse me. It should be 11.9. Okay, and that would be meters. Okay, let's go to example number 5. The diagram below shows the plans for a cell phone tower. A guy wire attached to the top of the tower makes an angle of 65 degrees with the ground. From the ground, 100 point from the end of the guy wire, the angle of elevation to the top of the tower is 32 degrees. Find the height of the tower. I'll call that x. Okay? So again, what I would recommend doing right away, find all the missing angles. Okay? So if I have a 65 here, that means the angle that's supplementary to it should be 115. Okay? And then if I use the 65 and the 90, that should give us a 25 to complete that triangle. And then finally, if I take 180, I'm going to subtract 32. I'm going to subtract 115. That should give me a total of 33 over here. Okay? So we're going to use our law of sines. Okay? So I'll start with the smaller triangle, the bigger triangle, the one with the 100 in it. 100 over the sine of the angle opposite is 33. Y is going to be the wire, okay? Because that's going to be the shared side. And then that is across, the Y is across from the 32. Okay? So we got Y sine 33 equals 100 sine 32. We'll divide by the sine of 33. All right. Let's my calculator here. We'll see what happened. See if we can get that going again. Okay. So now what I'll do is I'm going to type in 100 sine 32 divided by the sine of 33. And that should be, and again, we want 4 decimal places. I'll say 2973. And we just do 4 decimal places to be safe. We want to make sure that we don't round too early. Okay? All right, so now what I'm going to do is I'm going to take that value, okay, and I'm going to now start moving towards, I'll show you over here, the blue triangle. See this blue triangle right here? So I'm going to work with that triangle now. Okay, I'm going to take the 97.2973. Across from that is 32. Oh, wait, I'm in the wrong triangle. Excuse me. So silly. I shouldn't be in the blue triangle. I should be in the other triangle. The undo isn't working. All I'll just change it with this. Pardon me, the original work we did was in the blue. We're going to the yellow triangle now. Okay, so I'm going to take the 97.2973. That's across from the 90, isn't it? And then x is the side we want to find, and that's going to be across from the 65. So it's going to be x sine 90 is equal to the 97.2973 sine 65. We'll divide by the sine of 90. All right, so here we go. All right, I'm going to hit up, enter, so I get that number. I'm going to multiply that times the sine of 65. And then I'm going to divide that by the sine of 90. And they want this is about 88. Let me just double check the rounding. It does say to the nearest foot. So we'll say about 88 feet. Okay. So again, I mean, to kind of recap what we got so far is you want to always start in the triangle where you're given a side, and then you want to try to move into the other triangle. Okay. A lighthouse is built on a cliff near the edge of the ocean, as shown in the diagram. From a boat 200 feet from the base of the cliff, the angle of elevation to the top is 18 degrees, and the angle of elevation to the top of the lighthouse is 28 degrees. What is the height of the lighthouse to the nearest tenth of a foot? Okay, so in a question like this one, one thing I want you to realize is that if the smaller angle is 18, which I'll show you over here, and the bigger angle is a 28, which is the whole thing, what you should probably try to figure out is what's left in between them, which would be 10. That's going to be that skinnier angle. That's the difference between the two. Okay, we're going to have a 90 down here. All right, so now let's find, again, the missing angles in the triangle. So let's start with the triangle that's smaller on the bottom. I see a 90 and I see a 28. So if I add those up to 180, that should leave me with a 62. Then I'll just draw this down so it looks like we have a triangle. And then on this question, I think the way you would approach this one, well, I guess there's two ways to do it. You could focus on the big triangle. The big triangle, okay, ultimately looks something like this. It has a 90, and this would be a 28, wouldn't it? It would be the two angles together, okay? So I guess that takes away, this one shouldn't be a 62. I apologize for that. The 62 should be up here. In this case, that was an 18-degree angle, so that should be, 90 minus 18 should be 72. All right, so again, what's happening here is that we have in the yellow triangle, the 72, the 90, and the 18 make 90. And then in the big blue triangle, I think what I was trying to say here, the big blue triangle, you have a 90, you have a 62, and then you have a 28. All right? So that's a little bit of a tricky setup. I think what I'm going to start with is I'll start with finding y, the shared side. So start with the triangle that's they're given a side in. That's going to be the yellow triangle. Okay, that's going to be the 200 is the side. That's going to be across from the 72. And then y is the side we want to find. That's going to be across from the 90. So y sine 72 is equal to 200 sine 90. We'll divide by sine 72. All right, so go to our calculator. Let's see. So we're going to do 200 sine 90. And we're going to divide that by the sine of 72. Okay, so that should be about 210. What do we have? About 0.2924. Okay, so now we'll run it again. Now I'm going to go into the skinny triangle on the top. So I'm going to take that 210 number. That's going to be over now the sine of 62. That's what's opposite in the skinny triangle up top. X, and then this is where we need the 10, because the 10 is across the way from the X. All right, so 210.2924 sine 10 is equal to X sine 62. We'll divide by the sine of 62. All right, and I want this final answer to the nearest tenth of a foot. Let's go to our calculator. All right, so I've got the 210 number in there. So I'm going to go up enter on that one. I'm going to multiply that times the sine of 10. I'll close. We'll divide by the sine of 62. And that should be about 41.4, looks like. All right, last question. This says homework on the sheet. I put it as a regular question in our notes. That's okay. We'll do it right now. So we have a cliff, D. We have sighted from two separate locations, A and B, by S. If angle DAC is 30 degrees, I'll put that in the picture. All right, and then if angle DBC is 45 degrees, and S is equal to 30 feet, what is the height of the cliff? We'll leave that as H, okay? So let's start with the triangle that they give you information on, okay? We're going to find side Y, but we got to find the missing angles, okay? So again, the way that works, if they give you that this is 45, then the angle next to it is supplementary, that's 135. And then if we add up the 135 and the 30, you get 165, and 180 minus 165 should be 15. All right, and then finally, in the other skinny, smaller triangle, if you have a 45 and a 90, your third angle has to be a 45. Okay, so let's start with what we got. We got the 30 feet. That's opposite the 15-degree angle. Y is opposite the 30-degree angle. So Y sine 15 is equal to 30 sine 30. We'll divide by the sine of 15. All right, so we got 30 sine 30 divided by the sine of 15. All right, so it's going to be about 57 point, I'll say 9,555. We'll do that again now. So let's take that 57 number. So 57.9555 over the sine of 90. All right, and then H is what we want to find, and that's across from the 45. We'll cross multiply again. H sine 90 is equal to 57.9555 sine 45. We'll divide by the sine of 90. And they want this answer to the nearest foot. Okay, so here we go. I'll go up, enter. So I got the real number times the sine of 45. Oop. Okay. Divided by the sine of 90. All right, so this should be H is about 41 feet. All right, so that's how this sheet goes. I hope you see there is a lot of repetition in these questions, which is a good thing. One small little comment that I think I just realized when I go back to look at example number 4, the Y value the X value that we found was the X value of the triangle, which did not include, by the way, now that I'm looking at this again, the additional 1.7 meters. So we would have to add that on. So I want to not forget to do that. Okay. And if I take the 11.9 and add 1.7, you should be looking at about 13.6. Yeah, I guess that's a good reason why you should always go back and reread and recheck all your answers and look at it twice. All right, hope all is well. Talk to you soon.